SAT 22 for week 5. Here we go. So we have ourselves a table of values. For line H, the table shows 3 values of x and their corresponding values of y. Line K is the result of translating h down 5 units in the xy plane. What is the x-intercept of line K? And our traditional 4 answer choices here. Here's how we did. So you can see here, it's pretty close to being 3/4 of us chose green, answer choice D. Answer choice D did turn out to be the correct answer. Our second place winner, or maybe not winner, was answer choice C up here. All right, and as far as difficulty goes, it looks like it was somewhere around medium, maybe slightly skewed towards the easy side. So let's take a look at the actual solution. And as far as the solution goes, I'm going to show you a couple of ways to do it. The first one is by hand. I doubt seriously anybody did it by hand. The cheat code known as Desmos. And then I'll also show you how to do it on a graphing calculator, the regular TI graphing calculator in a separate video. Okay, so since it is a line, I know that it has some sort of constant slope, and our slope is a change in y, so like y2 minus y1 over a change in x, x2 minus x1, right? I mean, we learned that in somewhere around algebra. So all I have to do is pick 2 of the points in here and then cram them into my little formula, and I'm just going to select the first 2. I'm going to select the first 2 just because I can see that 160 minus 130 is going to be a little bit faster by hand to subtract, a little bit easier. So 160 minus 130 over, and now keep this in the same order. I went 160 minus 130, so I need to go 23 minus 18. So 23 minus 18. So simplifying across the top, I have 30. That's a 0. And on the bottom, I do believe that's 5 for a slope of 6. Okay, so my line has a slope of 6. And then as far as the y-intercept goes, I don't have that information in the table. I don't really need it in order to write the equation of this thing, because I can use good old-fashioned point-slope form. So point-slope form looks like this. Y minus y1 is equal to our slope times x minus x1, where y1 and x1 are just any point that is on this line, and I'm going to select our first point right here, the 18 comma 130. It's the smallest numbers in the table, might be the easiest to work with. Okay, so I have y minus 130 times our slope of 6 times x minus, and then our x coordinate goes with it is 18. Okay, so what I'm going to do to this is I'm going to turn it into slope-intercept form. Why am I going to do that? Because if I have myself a line, let me just kind of sketch some sort of graph here. And let's say this is my line. If this line here translates down 5 units, what actually translates down exactly 5 units is going to be the y-intercept. So I just need to find the y-intercept here so I can subtract 5 from it to make my line go down 5 units. So to put this into slope-intercept form, if you have forgotten, slope-intercept form looks like this. Y is equal to the slope times x plus b. Y equals mx plus b, the classic. So to get point slope form into slope-intercept form, you just basically isolate the y. You might ask, why didn't I start here? Well, if I didn't start with the point slope form, I would have to select my x and my y value, plug it in for x and y, and then I'd have to solve it for b, and then I'd have to rewrite my equation. So I always think that the point slope form is a somewhat faster way to start, because you have the equation of the line right here. And as far as Desmos goes, if you're going to type that in, Desmos will handle the equation in this form. Unfortunately, our TI calculators will not. Anyway, so let's distribute the 6 through here. And I have y minus 130 is equal to 6x minus, and then off to the side, let's do this multiplication. 8 times 6, that's going to be a 60 plus 48, which is 108. 108. Now I'm going to have to add the 130 over to the other side of the equation, right? So I have 130, then I'm going to subtract 108 from, I believe that's 22. And it's going to be a positive 22 because I'm adding the 130. So y is equal to 6x plus 22. So here's my equation. And if I were going to graph this thing, of course the graph that I have right here is not exactly accurate. We're going to graph this thing. I know that I would have an y-intercept of 22. I'll just say that that's what this number is here. And it has a positive slope, which means it goes upwards. It doesn't go downwards. So let's say it's going to be something along those lines. And whatever this x-intercept is, whenever I take this line and I move it down, you can see that it's going to move the x-intercept to the right, essentially. Now, it is a common misconception to think if this thing moves down 5, then the x-intercept is going to move by 5 as well. As a matter of fact, I think that one of our answer choices over here takes that into account. And I'll look at that whenever we get to some pro techniques here. Okay, anyway, so when I move this line down exactly 5 units, so this thing goes down 5, I'm going to get a parallel line. The reason why I'm going to get a parallel line is because the new line is going to have the same exact slope because we didn't change the slope. All we did is translated this thing down 5 units. All right, this 5 is going to get all up in my way. Here, let me go back. Erase this guy. All right. Yeah, my drawing is taking longer than the actual problem. So this thing is going to go down 5. And then it's going to put my x-intercept at some new coordinate. So one of the things that I can do right here is I can take this equation here, the one that I just got, and then just subtract 5 from the y-intercept, because that's the only thing that's going down by 5. Actually, all your y-coordinates would be going down by 5, but the one that we know specifically is the 22 that's right here. So if I just subtract 5 from that y-intercept, my new equation becomes y is equal to 6x still, so it's going to be parallel line, and then plus 17. Okay, and now what it's asking us to do is find the x-intercept of that line. So the x-intercept, whenever you graph a line or graph a point, if it's on the x-intercept, its y-coordinates, I'm going to put this as okay, is equal to 0. So I just plug in a 0 for my y-coordinates, and I solve this thing for x. So 6x plus 17. I'll subtract that 17 over, so negative 17 is equal to 6x. Divide by my 6, and I get negative 17 over 6 is equal to my x-intercept. And you know what? That right there is answer choice D. All right, so let's look at probably like I said, I doubt seriously anybody did all of this math. And in order to solve this problem, what you did is you opened up your cheat codes, otherwise known as Desmos, and just did the whole thing in Desmos. So let's look at that solution and see how probably the best strategy is on this one. So of course you want to first type in your table of values. Now I did take a look at the test version, like the test mode version for the SAT, and you still get to do little scatter plots and stuff like that. As a matter of fact, it'll let you do a regression line as well, which is probably what you should do here. All right, so let's pull up the Desmos, right, and then I'm going to side by side so I can see my table of values here. Okay, make this really, there we go. Now, so to get the table of values, you're going to hit the little plus sign in the upper left-hand corner, and you're going to choose table. So on the test version, you're going to have the f of x expression, you're going to have table, but the other stuff has been disabled. Not that you need it. Anyways, for the table, let's just type in our x values here. We have an 18, we have a 23, and we have a 26. Okay, and then come over here to our y values. And we have 130, 160, And there goes my voice, 178. All right. And so on the mobile version of this app that I have, it does not have a little default button that will allow us to do the regression model very, very quickly. And I doubt seriously that the test mode will either. So I'll show you how to do it both ways. So I have already taken the liberty of going over here to the web version of Desmos, and I typed our system of equation, our table of values in. And you can see right beside the little tiny number 1 on the left-hand side, there looks like to be a little scatter plot. Now, this is already scatter plotted. You don't see it on the graph grid right now until you hit the little magnifying glass over here on the left, and it'll show you where your points are. Now, you can move your graph grid around so you can see where, like, we're looking for x-intercepts, so I need to see the x-axis. So now if I hit the little button that looks like a scatter plot, it'll do exactly that kind of thing and give you a regression model. And you could change it if it wasn't a linear regression, you can change it to something else. Okay, and then you can see your line right here in blue, and you can turn it on, you can turn it off if you want to. You can also interact here, and you can see the original x-intercept here, which I do believe is one of the answer choices. It's one of the distractor answer choices. And now the statistics over here, the R equals 1, that's your correlation coefficient. This means that these points are dead on the line. It's a perfect fit, of course, because we have 3 points. It told us they were all on the same line. Now, you can't really interact with this equation, but just to the right of the equation, there's this little, it looks like a little table with a kind of a slanted arrow on it. If you click that, it brings your equation right down to box number 2. And that way you could actually change your equation, which is what we're going to get to. So I think all of those features, unfortunately, do not exist on the test version, but that's okay. There's a way around it. So the way around it is going to look like this. So on my second line, I'm going to type a version of the equation that's going to look like this. Notice that in our table here, you have x sub 1 and you have y sub 1. And that's how we're going to have to type this in. We're going to have to use basically the slope-intercept form of that equation, y equals mx plus b, and type those things in with variables. So I need to start with y1, and the 1, if you just put it right after it, it just assumes that you need the little subscript. The little 3-element list is indicating our table of values where the y1 has 3 specific elements in that list. Okay, now instead of hitting your equal sign, what you do is you go to your little alphabet keyboard and you're finding the tilde. And there's one right here on this bottom row of my keyboard, and then I think actually on your Chromebook keyboard, it's way up there above the number 1. Okay, and now I'm going to type in mx sub 1. So I need to put the little 1 after it, and then put a plus b. So you go back to the alphabet, put a plus b, and you can see the equation is exactly the same. It has the statistics with the R value correlation coefficient of 1. It has parameters m is equal to 6, and b is equal to 22. So unfortunately, unlike the previous version of this, I can't just easily take that equation and then have it go down to line number 3 for me. So instead, what I have to do is just type it in. So I just come down here to line number 3 and then type in y is equal to. It gave me an m value of 6, so 6x plus my 22. And there I have it. There's my equation, my line. I can go back over here to the little zoom fit, and I can see my whole line. I can see where the x-intercept is if I just tap on it on the screen. But now what I need to do is move this equation down 5 units. So I'm going to go to the next line and basically subtract 5 from the 22, the y-intercept, which is going to move my equation down 5 units. And that's going to be y is equal to, that's a plus sign, y is equal to 6x, and then this one's going to be plus 17, I believe, right? Okay. And now if I zoom in here a little bit, I can make it a little bit easier to find my new x-intercept here, which is negative 2.83. So look at the decimal here. Like if I did this whole thing on decimals here, I can get my answer, and I can actually type this. I can tap this little button that'll bring my bring my answer over there to box number 5. But the decimal there, the 0.83, so you can type your answer choices in to see if it matches up. You really don't have to, because here, if I go back to my little answer choices, oh, it's this one. If I go back to my answer choices, this first one here says I'm dividing by 3. If I'm dividing by 3, it's going to be 0.33333 or 0.666666. If I'm dividing by 2, if it doesn't go in evenly, it's going to be a 0.5. Again, a 0.3 or a 0.6. The only one that's going to give us something strange is right there at that last one. So you could just go straight to that negative 17 over 6. And just, for the sake of some confidence, you can type that in, negative 17 divided by 6. And there you go. You can see that exact decimal number. Okay. So if we go back up here to, I believe it's our purple line here, which was the original, and its y-intercept was a negative 3.666666. So let me just write this one down here. So a negative 3.6 repeating is the same thing as a negative 3 and 2/3. And if I convert this into an improper fraction, which is what all of these things are, the 3 times 3 is 9, and 9 plus 2 gives me a negative 11/3. Negative 11/3 is answer choice C, which was our second most popular answer choice. So essentially the original line's x-intercept.